NVIDIA just came out with a very bold statement. In a recent interview following the NVIDIA GTC conference, Jensen Huang declared that OpenClaw
This is definitely the next ChatGPT.
And with that statement, NVIDIA just released their updated stack of OpenClaw that they are calling NemoClaw. And in the past few days, we've seen a really high uptick of OpenClaw usage following this announcement. So what is the big deal with NemoClaw? Is it really as revolutionary as NVIDIA advertises? Well, that's what we're gonna find out. In today's video, we'll take a look at NemoClaw, see how it works, and we'll try it out for ourselves. It's gonna be a lot of fun, so let's dive into it. So what exactly is NemoClaw? Well, at its core, it promises a secure enterprise-grade environment for autonomous AI agents. While the base OpenClaw platform is powerful for automation, it seriously lacks the security oversight needed for professional or sensitive workflows. NVIDIA designed NemoClaw to bridge this gap by wrapping the agent in kind of a safety sandbox that monitors every action the AI takes in real time. And honestly, they might have overdone themselves, but we'll discuss that later in this video. So NemoClaw is essentially an open source stack that moves the OpenClaw agent into a secure environment called NVIDIA OpenShell. And it works by using what NVIDIA calls a blueprint. You can think of it as a master Python script that orchestrates the entire life cycle of the agent, from creating the sandbox to overseeing the security guardrails. And once it's running, every file access, network request, and inference call is governed by a declarative policy. If the agent tries to reach an unauthorized website or access a restricted part of the file system, OpenShell blocks that action and flags it for manual approval in the terminal. This effectively adds a managed infrastructure layer beneath the agent, allowing it to be productive while remaining inside strict security guardrails. Now that might sound great in theory, but how does it work in practice? Well, let's try to set up our own NemoClaw and see how it works. So the easiest way to get started is by going to NVIDIA's NemoClaw page and click on the Try Now button. And this will take you to NVIDIA's Brev service page, which is essentially their preferred cloud GPU platform. Brev provides pre-configured environments that already have the NVIDIA drivers, CUDA, and Docker installed, so you can get up and running with a ready-to-use deployment for your NemoClaw agent. And if you set up a new account, NVIDIA does provide $2 of free credits, so you can basically test out your first deployment for free. And once we spin it up, we can use the Brev shell command to connect to our deployment, and from here, we can run the NemoClaw installation script. And right off the bat, we can see that the default script provided here by NVIDIA fails to install OpenShell, so that's a bit annoying. But if this fails for you, you can just manually download it from the NVIDIA's GitHub repository. And first, it will ask you to provide the name for your NemoClaw agent. You can just leave it as the default My Assistant here, or name it whatever you'd like. Next, it will ask you to provide your NVIDIA API key. So make sure you have one set up for this purpose, otherwise NemoClaw might not work properly. And then it will also ask you to choose your inference model. And here NVIDIA is advertising Nemotron as their go-to choice for running NemoClaw. So I'll choose that and see how well it performs. The installation takes about a few minutes to finish, but once that is done, I would advertise as the next step to provide your Telegram bot token so we can connect our NemoClaw agent to our Telegram app. Next, we can run NemoClaw start. And if you see all green check marks, that means we have successfully kickstarted our agent. And from here, the script advises us to open the OpenShell manager, which is basically NVIDIA's TUI blueprint interface, which lets you oversee the whole system and manually approve or deny any incoming network requests. And as soon as we launch it, we can see here that there's already a pending request that we need to approve for NemoClaw to continue to function without disturbance. We can just click A here to approve and then go back to the overview. Next, we need to connect to our NemoClaw agent and then launch a gateway to make sure we can chat with it through Telegram. And this is where NemoClaw starts to get finicky, because launching the gateway can sometimes get tricky, because sometimes you need to manually kill the previous gateway to start a new one. So at this stage, it's still very buggy. And the Telegram bridge seems to be unstable as well. But most importantly, I found that the inference speed of NemoClaw is super slow. I don't know if that's just because I'm using NVIDIA's Nemotron model, but sometimes it takes NemoClaw up to 2 minutes minutes to reply to me on Telegram. And you might also get an issue where the Telegram bot returns a 255 error code. And if this is the case, you should exit the OpenClaw shell and in your deployment container, kill any outstanding Telegram bridge processes. And if that doesn't do the trick, you should also go through the OpenClaw configure command wizard and make sure to add the Telegram bot token there manually. So you can see how much setup I have to do here just to start with the very basics of running it. So with all these little annoyances, I ended up struggling quite a bit to get it to a stable place. But once I finally got it somewhat functional, I decided to try it out by asking NemoClaw to make me a cron job that sends me the newest Hacker News articles every 3 minutes. And here's where NemoClaw becomes really tedious to use. You see, in order for NemoClaw to successfully execute this type of cron job, it has to go back and forth on OpenShell and manually approve every network request that NemoClaw tries to make. And you can imagine that for more complicated workflows and tasks, you would need to really babysit NemoClaw quite a bit to get through all the outbound network requests by manually approving each one of those. And not to mention, you need to prompt the agent several times to let it retry the network calls a second time once you approve them on OpenShell. So you have to go back and forth all the time. I think this seriously kneecaps OpenClaw's ability to run autonomously because the security layer is just too strict. As for my own test, after several back and forths, I finally managed to task NemoClaw to send me a fresh batch of Hacker News articles every 3 minutes, but it took me half an hour to get it to a working state by constantly babysitting it and monitoring OpenClaw logs and making sure that everything is running smoothly, and making sure that NemoClaw is able to set up everything correctly on its own. So I think this is the part where the whole idea of NemoClaw starts to become very, very complex. NVIDIA does provide additional commands to put specific security policies in place, but for now those commands are very limited and they don't provide a sophisticated way to create custom tailored security rules. I understand that this stack is still very new and fresh, and hopefully eventually down the line, it might actually become stable enough to incorporate it into production environments. But to be honest, for now, NemoClaw feels very, very unstable and very hard to use. But those are just my observations of NemoClaw. What about you folks? Have you tried it? Do you like it? Do you struggle with it? I'd like to know your thoughts, so let me know in the comments down below. And folks, if you like these types of technical breakdowns, please let me know by smashing that like button underneath the video. And also don't forget to subscribe to our channel. This has been Andres from BetterStack, and I will see you in the next videos.